next one discussing the role of engineering manager, but with the caveat of can the one do that successfully without knowing how to code? So take this as an open invitation to join that one. And today, that's it. Today we're going to discuss microservices. The way we came up with this topic is that it's an actual interesting topic in Vinted. So for however years we have been coding our application, our product, it grew into a pretty big monolith. And then some of you probably are very well aware of the transformation we are going through of chopping up the monolith. One of the ways to chop it off is to split it into services or microservices, and then we could have a classical picture. The slide is not flipping. I see it on the screen, I don't see it here. Yes, the classical picture. We'll not go into that. I'll show you the picture that I find amusing. And that's the picture of our components in our core monolith in Vinted. And you can zoom in a bit more, and you can zoom in a bit more, and it gets worse and worse. I didn't want to do one more zoom because you might deduct some things about our code that we probably wouldn't want you to deduct. So, as you understood by now, we are on a journey in Vinted, and therefore we wanted to invite a couple of good colleagues, good friends, to discuss how to and get smarter in that journey of chopping up the monolith. And the way we discussed this theme, and I hope it would be a continuation when the speakers are on stage, is that sometimes this topic gets overly religious. There are people who have a microservices tattoo on some body part, and there are people, I know less of these people, who have monolith tattoo on some body part. And therefore, we'll have two speeches, one from Vix and one from Boost, and the second one will be a bit of a duel, monolith versus microservices. We'll see who's having which tattoo. Our journey actually doesn't look anything like this. Our journey actually looks like this. And the next thing I want to do is to actually flip my screen to Slido. So please take your phones. You can enter either tech leads in slido.com, or you could simply scan the barcode. And then I'll just share other screen now. I'll do this. Yep. So, for our upcoming speakers to get a bit of an idea what audience we have, I'm a scale type of person. So I recognize that the world is not binary. There's no yes or no answers to pretty much anything. So instead of being binary, I'm a scale person. So instead of saying yes or no, I'm asking from 1 to 5, slim to none, expert, what is the audience? Hopefully that will give some indication to the speakers, or not, because half of you are somewhere in the middle. Hope it will be useful to you. So that being said, I would like to welcome Vilus on stage. I'll just flip the slides.
Hello. I will need a clicker or something, or you will do the... Okay, so anyway, on the previous poll, I gave myself a free. Actually, though, I'm talking on microservices. And today, I want to talk about, basically go over, wait, will I know how to operate it? Hopefully. Pros and cons of microservices and if they are real. And, I want to talk about it through perspective of company where I work at. And, we're on the microservice journey. So, hi, I'm Vilus. I'm 8 years in Wix. throughout my long tenure, really. I went through individual contributor, team lead, guild lead, and now TPM, which is like, I just didn't have enough space, really, technical product manager. So like a little less hands-on and more on to, figuring out what to build and how to build. And also, mostly I code and coded on JVM and Scala, with Scala language, and somewhat on Node.js and JavaScript. And mostly in backend, but I did take some trips to a front-end land as well. So, okay. So if you go on, internet and try to Google up something on microservices, you can find different kind of material, right? You can find some legitimately good sort of material like Building Microservices by Sam Newman, amazing book. You can find some good advice like Monolith Thirst by Martin. There is obviously some controversial topics, right? Catchy, like stop, you don't need microservices, you want modules, and or actually content, I think, is a bit moderate. Another type of material you can find is, companies trying to sell you stuff, right? To build microservices, to run them. And what caught my eye is that there is another class and more of those. Like, what are the benefits and sort of pros cons of microservices, right? So some companies, like Sam talks about it. Some companies share their experience, but. So I figured, okay, I work in a company that's doing microservices for 10 years, and it would be interesting to introspect and see, like, if those pros, cons, I consider them at least real, like, pros as advantages, and did cons really materialize for us? And just to remove sort of source bias, I don't know, everybody does that now, but anyway, I asked ChatGPT to give me like 5 pros, 5 cons, and I'll just run with those. Though, to be fair, I will talk about 3 of each, because otherwise it would take too much time, and I selected the ones that I find interesting, or where I think I can give some interesting story. So, short agenda. I want to talk a bit about context company because it's important, right? The sort of my introspection is based on my experience. Short timeline of microservice journey, how we get to where we are, and then go over pros, cons, and sort of TLDR at the end. So, I'm talking about 10 years period, right? So Wix 10 years ago was basically a site builder, like you can build your site and you can serve it. It was a Flash editor viewer, right? So the thing that is dead now, thanks to Steve Jobs. And it was, monolithic app, like nothing really dynamic except, of course, for the view, but no integrations, nothing. It was like good old monolith. And Wix 10 years later, basically it's like a totally different set of products. So instead of one editor, we have at least 3, which is classical, Editor X, and ADI. We did expand into what we call verticals. So under the shell of Wix, you can build a store, you can set up events, you can write blogs. So these are like stores, bookings, you can do email marketing, like a lot of stuff which like apps, which you can add to your site, and basically support your business. Another sort of change that we did is basically we added Velo. So sites, you can build your site and its behavior not only by what we envisioned and added to the products, but actually you can write code, extend our products in a way that you need, right? Maybe there is a bit missing, so you can do that. And also we expose much of functionality through APIs. So you can even build mashups and, serve them via Wix. So again, over 10 years, as you can see, sort of complexity of the size of the company and complexity of our product suite really changed a bit. Timeline. So this is roughly the timeline. This is not, like precise graphs, but you can imagine. So we went in 10 years, or maybe it's 12, but good enough, from monolith to basically 2,200 microservices in production. And these are only JVM microservices, whereas our backend, the organization, we have like 500 backend engineers. So this is like, some of you might think like, why you do this to yourself? But actually, I think it works quite nicely for us, and we don't have huge issues in managing this. Now, some you might find interesting events and related to my next pros cons. So I think like, from monolith up to like 20 deployables, we applied the good old copy-paste pattern, right? Basically, we have a monolith, we add more features, now we start breaking each other, we deploy, we have production issue, roll back, unrelated things impact each other, right? Usual story with monoliths. So what we did, we sort of copy-pasted. You copy-paste, clean up, one is for viewer, another is for editor, and then there is some common functionality eventually, right? Okay, you copy-paste again, you extract it, now you have free. So I think we did this copy-paste up until like 20 deployable, like, I don't know if I can call it like services. They were sort of services. And then we understood that, we cannot continue like this. It will not take us far. So basically at around 2014, we sort of extracted common code base as our internal framework. We eventually changed our artifacts to run on that framework, right? And instead, for example, when you have 20 copy pastes, you figure out you need to change some, do a change on the, let's say your interop stack. So now you have to do it potentially 20 times. So framework and shared code base allowed us to sort of eliminate that. And we went with it up until like 2017. But in the meantime, we added additional runtime, stack, Node.js. So up until that, we were JVM only. And in 2019, we sort of introduced a next-gen framework. So it was async. We used gRPC proto for inter-service communication. Yeah, it has different code name, but good enough internal framework v2. And 2020 was a change where we shifted sort of from building apps and sites to changing how we build products to API first. So it's not you could consider this not a huge change, but sort of to enable this customizability and eat our own dog food and make it happen. This was like a huge, let's say, cultural change for us. Okay, so let's get to the meat of the talk. Advantages. Pros. And I'll have Drake here to give me hints if I agree with any of those or not. And let's start with the first one, scalability. So ChatGPT says that microservices architecture allows for easy scaling of individual components. So do you say it's true, false, or depends? I saw depends, true, false. It's true, like Drake says. And really, like I was a bit lazy on this one, and I just took data from production. So I did anonymize it and remove numbers. So basically, this is the number of instances per service over time, right? So basically, you can see that this service potentially has like 30 instances or something. But I removed it. But the interesting thing is that as you can see, there is a lot of congestion on the low end, which would be like service has 2-3 instances, let's say, per data center, but there is still variance, right? So basically, we do use this that, so there are some more heavily loaded services. There are usually like some less heavily. So, the scaling, like we really apply it, we auto-scale. And this is the histogram, so different view of that data. And still, there is a lot of congestion on the low end. Let's call it 1 to 5. Right, but there is also a sort of a long tail. So, this could be sort of public viewer services, popular apps, for example. So I would say it's true. And, we can see from production that we do have different load factors on our services, though microservice architecture can be a contributor to higher variance, right? So basically, if you sort, you can have still in monolith. You can you can do something, do some preparation on the sort of entry, do some thread local, let's say share state, pass it along. In microservice, you cannot do that because there is boundary, for example, right? So there could be some popular microservices, and then you get this data. So it is true for us to some extent, but also we do apply patterns to sort of eliminate this unnecessary variance. And I'll talk about them later. Now, second advantage is resilience. So in microservice architecture, if one service fails, it does not bring down the entire system. True, false? Everything is eventually depends. So, false. And I guess, I'm arguing against like common sense, right? Because technically microservices, they are separate processes, right? And in a decent OS, if one process dies, it shouldn't sort of impact anything else. But, from the sort of perceived resilience, right, for users' perspective, like the fact that my service, like only part of my system died, but my system is not built in a way to be resilient to it, like it's irrelevant because, well, my system is giving now 500 responses. So system is really just as resilient as you make it. And yes, there is some true, but I think it's a bit negligible, at least from my experience. And in Wix, the way we sort of look at ourselves, I guess, at our infra, so we have like two segments, editor and viewer, right? So editor is where our users, paying customers, they come, they build their sites, manage their business, let's say interact with their users, set up their events, so right? And viewer is when they publish, it goes over to viewer, and this is where their users come, buy on their shops, read their blogs. And for us, these are totally different SLAs. And for example, in viewer, while microservices could be a contributor, but really we spent a lot of effort to make it resilient and like never go down, right? We trace each dependency. We add fallbacks to anything. We fallbacks upon fallbacks. Basically, half of Wix infra is down, but viewer needs to be up still. So this is how much we put effort into it, because it's definitely not cool being cloud company and when your users like cannot serve their users, sort of. This is really bad. While in editor, we're a bit more lax, right? If let's say something is not working for 5 minutes, so our user, well, he cannot drag something on the editor. He can go make himself a coffee, right, and come back, and it works. So we do prioritize, for example, not resilience, but we do prioritize adding new features, capabilities, right? We still, I mean, it's still generally not cool to have like downtime or interruptions in your system. But again, we definitely prioritize different things, and this is like the thought and engineering that makes your system really resilient. And I wouldn't say microservices have a bit to it, but really not too much. Last advantage, agility. So microservices enable faster development and deployment cycles. Do you agree? I heard agree. I guess there is somebody that should disagree as well. So it depends. Okay, so I got one. It depends as well. And this is a bit loaded. You can think about many things. what like faster development, deployment. When I think about it, it's just how much of unnecessary code developers need to write. So I think this would potentially can kill your development speed or evolution of infrastructure. And also how easy it's to integrate, right, and build products, sort of mash up services, reuse functionality. And deployment is just obviously, right, how easy I can deploy my services. So, and depends, because with the right investment, you can have, I think, these fast deployment and development cycles. So this is, I decided, to take something from close to our production. Basically, we use Proto for API definitions, right? IDL, interface definition language. And we sort of use it and abuse it to some extent. But basically, this is how me as developer define my API. And the nice thing that it's really declarative. And for example, when you read this, let's say there is RPC, create wish list. So this is my service exposes this method. Second line is, it's also exposed through HTTP post v1 wish list, right? So there's declaration, systems around it can read it, understand it, because it's declarative. Also, framework does this dual exposure automatically. So me as developer building microservice, I don't need to do anything else. Right, there is a contract, it does sort of deserialization and handling of request payload and so forth. There is also, let's say, permission. Again, given it's declarative, framework checks permission for me. So it's checked before it even gets, I get sort of into my code. And also, so there is some other stuff, but also there is, let's say, callback. So also semantically, it says that this method, as part of its execution, emits event. So to the outside, let's say, it emits a webhook. Locally, it's, let's say, event, Kafka event. And as a developer, basically, this is what I need to implement. And by doing that, I get logging, central logging, I get metrics, I get context passing. You don't need to understand Scala details, right? But this is sort of taking care for me. And I do focus on, and this is like really stupid code, right? Like I take a request, map it, insert into database, return. Production code would have at least way more ifs, right? To be meaningful. But sort of, so, there is a definition of API. We try to minimize how much developer needs to write of unnecessary code. And the nice thing that, when I push it to master, it ends up in our docs. So basically now, and sure, like to make it really usable, you need to sort of add more comments in your API. But really you can, if let's say I'm building a product in Wix, I can go there, search for stuff, find a service. Now I, can read through API, see if it works for me. If like I'm still unsure, I can find who runs this service. But so for me, like discoverability is really nice because it's declarative. And if I find some service, okay, it works for me, I want to integrate with it. Again, this is some service. It has like deployable artifact, not actually FQN. What I do, I add it to my build descriptor. Right, and I build and I get a client, RPC client, wired. Basically, I don't need to do anything in production. Otherwise, that's all I need to do. And I deploy, and that's it. I can call this API and integrate. Same would go like really similar story with events, right? If that API emits some events, I can easily hook up in declarative way because types are known. Cogent can work with it. So I think, this is nothing really special, but I think this is a nice integration story where you can gain from microservices because you can easily integrate with your peers and get the benefits of reuse. Now, on deployment front, if you ask me, I think there should be at least 2 less steps to be optimal, but basically this is what we have. So to get a new microservice, like one thing is, how fast can you get new microservices into production, right? I need to build something. So it's an hour, I guess, in Wix, basically. We have IntelliJ plugin. I generate scaffold new service, push it to master. I go to internal tool, like basically set some metadata, right? Coordinates, couple of instances. I do go to another tool, GA, general availability, and basically it goes into production. Right, so maybe it's not yet ready to do anything meaningful in production, but also as a fact that we have sort of this framework, runtime, and declarative. So now, and all our services run on the same framework. So basically, our deployment system really can understand shape of its unified shape, and we can automate the deployment. So when I deploy it, I actually get automatically generated Grafana views, metrics, and alerts, right? So then, getting microservice, setting it up to production, like it's not a huge drag. And you saw, we have like 5 services per engineer. So if I would need to play with each of them, it would be like, ooh. And yeah, and next one is basically just push to master, builds, GA, chill. Cool. Disadvantages as per ChatGPT. So first one is complexity. Microservices can be more complex to develop and maintain than monolithic architectures. Do you say it's true? I see one. Yep. Me and him agrees. And basically, I think, Martin Fowler was right 8 years ago. He's just as right today. If you start doing I would say that at least 10% of our engineers work on infra, right? Productivity infra and so forth, right? So it's like investment. So for our size, it's okay, and it's a multiplier. But if you start, now you worry about product traction, getting money, getting customers, don't bother, because even all the sales pitches, there is still additional things to worry about and do, just don't. I think it does add complexity. You can deal with it, but it's still there. Disadvantages: increased latency. Communication between services can introduce latency. Who argues with that? So, and I say it depends. Again, I'm arguing basic physics, right? Because, well, communication, basically your bits, atoms, whoever needs to travel longer distances, needs to be serialized, deserialized, this latency, right? How can I argue it? But efficient serialization, deserialization protocols and patterns are your friends. So definitely, latency is there. But unless you're building sort of fractional trading or real-time system, I think it's a price worth paying. And I'll just give a couple of patterns, nothing really fancy, but something we do. So basically, we have a write flow. Request comes from browser, service A needs to write, but also service B needs to write, right? So you need to do some kind of orchestration, and this is your latency, right? And it's not even, for sort of latency, even for resilience, this is not great, right? Because you can have 10 of those. And now one fails, what do? All these decisions are hard. So what you can do is, when I show that we have proto and sort of events defined, right? Basically, you can just eliminate it. And service A instead emits events. In this case, I write my data. Maybe I set temporary state, I emit event, and service B can react, right? Write its data, send it back, and basically you basically push the non-critical work to async. There are some details. Maybe it sends event to itself and then pushes, but it's more architectural decision. But this sort of event-driven, whenever you can, it does eliminate latency. Now the read flow is more interesting, right? Because technically, you need to return. While in write you can API just return ID, nobody cares. But in read you need to return all the needed data. Right, and you have the same picture. In order to return complete data, service A needs to call C, B, D, right? It could be many. And then, you know, and on read, obviously you want to be quick about it, right? You don't want to take your time because your users will just be gone. So this is a bit more controversial. So what we do, and more like play and apply carefully, is sort of materialization pattern, right? So during write flow, service C, let's say, created some data that service A will need, so it emitted event, and service A actually does continuously create a projection of snippets of data it needs. And now when request comes, it doesn't need to talk to service C because it has like this copy that it needs and can return in a single take. So again, this is a bit tricky, right? Because if you lose events, now data is not in sync. What do you do about that? There are these details, and they are not simple, so we do apply these patterns where applicable, right? Where we do really need it because it does have cost. Cool. And last one, operational overhead. So managing multiple services can be an operational overhead. Like I got one yes, and I don't remember. Yes, it can. I mean, the way the sentence is framed, you know, you can go anyway, right? ChatGPT was like unassertive in this one. So definitely it can. And, you know, and when I show that, you know, for us, like by numbers, one engineer operates 5 services, which is like, so if you really need to, you know, work with them, it can take really a lot of your effort that you otherwise would like to spend on products, and tooling and automation is needed to minimize overhead, right? It's there, but you can actually automate your way out of it. And I'll just give like a couple of snippets that I think we have, like nothing, no magic here. So, for example, when I work on my microservice, right? So we don't do the continuous delivery sort of per se. We have continuous integration, but there is like a human step in between. So when I do my changes, I push my sort of codes to master, test run, artifact is built, I get a Slack notification, and what I do auto GA. It means basically, you know, I want it deployed, I don't want to look at any graphs and worry about anything. I want the system to tell me if something goes wrong. And the fact that our services like run on shared runtime framework, basically deployment system has like, and we have, you know, shared common metrics, deployment system knows, right? It can deploy a node, see your metrics, graphs, like if there is alert, something is not right, it can stop and notify you. So this is some buildup we do have. And also, this is like, I don't know, awkward thing, but also there are a lot of changes in, let's say, framework infrastructure, right? And we want these new things to be deployed. Let's say we improved something, we maybe fixed 0-day or something. We want them, like all the services to be GA'd, but we definitely don't want to like all at Wix, GA your services, which is like, why? So we have like, we built a simple service, GA enforcer, and what it does actually, it just GAs my service every week. And given, you know, given we have this and that, basically, it can do the unattended. It GAs if there is, you know, redirect some traffic. If something wrong, it just goes away. Like, okay, I won't do that. But basically, so this is one of the services I own, and I didn't even know it's being GA'd. I just, you know, for this presentation, like, oh, it's there, it's happening. So again, you know, there can be cost on many levels, but there definitely are ways to sort of think about it and build a framework to mitigate those. Cool, so TLDR. Microservices are great for organizational decoupling. Not in any way related to what I talked, but it's still true, right? So our size, many product teams, I think we have like 50 product teams or something working, right? So I don't know how else we could operate. So, and this like, you know, this sort of ownership, decoupling, like there are so many things in this different talk, but it's really great. Martin Fowler was right, and still is, monolith first. Yes, different SLA scaling is a thing, and I think one thing is investment in platform is essential. So like if you do it right, do the right investments to sort of not get bogged down by the infrastructure or amount of services you have, you can have like a pretty good life. Thank you. And questions will be at the end.
Yes, questions at the end. Thank you, Vilus.
Cool.
Everyone, it's great to be here, and a great presentation from Vilus. Whilst he presented a bit more about technical matters, he dig deep into technical matters, we will be a bit more soft on the side. We're going to present a bit more about the organizational matters of microservices versus monolith. So let me introduce myself. My name is Edvardas. I'm Director of Engineering at Boost. I started in 2017, so quite a while ago. Started as a software developer and grew together with the company. I'm happily married, no kids, but I have a cat and a dog. And in the picture here you can see my dog, who wasn't a fan of long hikes, long walks. So I had to carry her. I also love working out, but I enjoy great food, which probably is a bit easier to tell.
Yeah, I'm Marco Rosselló. Can you hear me properly? Marco Rosselló, Web Development Director. I started in 2016 as a contributor and grew team lead, manager, and right now as a director. Husband, and I have a little boy that takes a little bit of my spare time, but it's really good fun. I recommend it. Yeah. Hobbies, sport, triathlon, and lately I got myself some cross-country skiing. And the best comment I got from a colleague of mine, a friend of mine, said, "You are very Spanish skiing." So it's not my forte. It's not my best, but it's fun. You can enjoy the winter here in Lithuania. A little bit about us. I think it's important to understand the organization, so we understand what we are going to discuss. So we are a technology company selling online, fashion online, and also a little bit of home. We have about 3 million active users at the moment, 15 stores, all in Europe. About 600 million net revenue if you convert from Swedish krona to euro at the moment. And we grew 60%. That's also very important for the discussion, the growth.
Yeah, enough of business numbers. Let's talk about people numbers. So we have around 1,000 employees in a Boost group. And from this 1,000 employees, we have around 200 of them in development, in IT, and 50 are working here from Vilnius office. We also like to develop stuff, business critical applications that we work with. So that's what it means, tailor-made systems. And behind Boost.com facade, there's a huge operation. As you probably imagine, we have a warehouse which has the biggest robot managed or robot operated AutoStore installation in the world. So let's get to the main topic, microservices. And just a bit of the theory, I will not bore you. Micro means the size, services means that it has some sort of definite function, a function that it has to complete. And basically, micro also, it emphasizes the importance of granularity. So to get microservices right, you have to really do it properly in terms of granularity. And there can be many aspects. I will emphasize two of those. First of all is data, and then is operational aspects of your company, which will help you to achieve your goals. And here you can see a simple microservice. Basically, it shows that it has database, it has functions, it has clear boundaries around it, and it has an interface. Really simple, right? A bit more of theory. Conway's law, probably you have heard it about. Basically, it states that the systems that people design reflect on the communication patterns of the designers. And how does it tie in with the microservices? Well, microservices, when are done right, this is the emphasis, done right, they work in harmony with organizations' communication patterns. So what are those communication patterns? Well, people sometimes can be good communicators, can be bad communicators, but when it comes to the teams, to groups, team versus team, group versus group, they are quite terrible in communication. Meaning that if you want to to make them work effectively, you have to establish some sort of clear interfaces to give them ownership and autonomy. So this is one of the first advantages, and actually in my book this is the biggest advantage, that microservices, they add natural boundaries around the system and they give ownership and autonomy to both code and the data. Similar as I/O can be a bottleneck for the system, the same goes for people as well. When you have to communicate, it can be a bottleneck for development velocity. When I'm talking about the communication outside the team. Within the team, that's a bit of a different story. So if it's true, then the goal would be probably to reduce the unnecessary communication, the unnecessary chat. So that means that if you put clear interfaces, that makes the whole organization a bit more agile and, well, promotes good organizational culture. Yeah, and there are, of course, other practical benefits that you get from microservices, and they were already touched upon, so I'll just quickly run through them. As a team, you get to choose your technology stack, you get to deploy things separately, you don't need to sync with anyone, and then you are in control of the data. You decide what is hidden and what is public. So Marco is probably dying to give some counter-arguments, so I'll give him space.
Yeah, microservices, but haven't you heard that Elon Musk is shutting them down? I've heard that's already passed, and now it's like time to kill them. A little bit more serious. So network, that's the biggest issue. When you put network, you come something is unreliable. It sounds like it should be fine, it should work, but it's not always the case, and we experience that. It's probably not secure also. You can work around it, you can have different, but overall you should not trust network. And increases latency. So that's some of the disadvantages. It is more complex. As a software developers, we try to make things a bit simpler. The simple, the better. If you make things more complicated, probably you're not going towards the right direction. You become into a risk of having a distributed monolith where you need to actually deploy them at the same time, because if you deploy one but the other one doesn't change, then so it's very easy to fall into that. Not splitting things correctly, you end up in a big mesh, but no advantages. The granularity, that's an interesting topic from Vilius. One developer, 5 systems. Okay, that's bold. For us, it's a little bit different. But to get it right and to make sure it works for the organization is also very, very important. And it's very easy to get it wrong. And versioning. Very likely you will have to introduce versioning, because one system will update a certain time, the other system doesn't want that feature. So again, we have more complexity. More work. As you heard, I'm Spanish, and that's the most painful. Why would you work more when you can have just one system and you don't need to do anything more? Reliability. Every single system new you introduce, the client needs to be failover and the system itself. Because if the system has a failover, but you don't trust it fully, the failover can fail. 2 is 1, 1 is none. So failover is another thing you need to consider and you need to actually implement. Load testing, probably you need to make sure that also scaling properly and you load test it. Oops. Yeah, there is quite a few things you need to include there. I guess you get the point. More work. Have you heard of monolith? I think it's a new idea, actually. It's like quite cool. Microservices are dying, and Elon Musk actually approves monolith. I heard it work out very well. It is simple. It's only one system. So it is simple. And actually, I really like to think when I do architecture into physical systems, and a warehouse is a great example. In a warehouse, you have something coming in, you store it, you process, and you get it out. It's exactly like a service would do, micro or not micro, as it would do. So if we start something new, definitely you wouldn't start with multiple places and so on. You would start with one. And then once you grow, you can decide whether or not you want to split it. You understand the users, where they buy from, where they don't buy from, and so on. And then you can break it down into better cases or have even a bigger warehouse and keep the monolith forever. Depends how successful you are. And it is faster. There is no network. It is faster. That's it. Join in database. That is it. No network, no latency.
Yeah.
I guess someone, yeah.
Yeah, so basically what Marco is saying, that if you want to do things right, you have to put more work and effort, right? What a shocker. But, well, now here you come to the main monolith disadvantage. And it's actually very similar to, actually it's not similar, it's opposite to what microservices offer. It's lack of ownership and autonomy. What happens to a thing where everybody and at the same time nobody is responsible for? Well, it becomes over time a big ball of mud. And at the beginning you probably still remember the component diagram that was shown here. It's a mess, it's a ball of mud. Now, another thing is if you want to evolve the system, if you want to make it better, to improve it, it becomes a group responsibility. And as managers, probably you know that group responsibility, and by group I mean not a single team, but a collection of teams working on different issues, group responsibility equals nobody's responsibility. So over time, the system becomes very complex. There's a lot of crosstalk between modules. There's a lot of joins, probably, in the models that nobody is accounted for. And probably the person who added is no longer there, but you still have to deal with the consequences. So basically, now let's talk about our case.
Yeah, I think it's enough of theory. Let's go actually to the practice. So let's show the code or the diagrams. There will not be any code in this presentation. But here's a very simple representation of our services. We have way more and way more microservices, but I just wanted to keep it simple so it's clear. So we'll talk about the web shop, is what our customers are using, the actual paying customers. We have Parcel API, which is the first microservice we split it. We have a stock service, and a stock service actually is shared between most of our systems. Internal, the warehouse cares about it, finance cares about it. Apparently they want to know what we have, and also our partners care about it. So let's talk first about the biggest. So we have a big, what you would call monolith. We have modules inside. Each of those modules are owned by separate teams. So they are also part of the same service, but they are owned inside by different teams. It's simple. It's one system. It's one database. It's one CI/CD pipeline, even though we saw that there is ways to have microservices following the same pipeline. But still, it is simple with multiple modules inside. What are the challenges of that monolith? So scalability has its limit. One single service can scale. We have PHP as a programming language, so it scales horizontally quite nicely. You can also scale a little bit the database reads can scale quite easily. You can add more read replicas. It scales quite well, but reads are okay. Writes and updates are not so good. So there are parts of the system that don't scale so nicely. We have quite a few people working, between 40 and 50 people. We follow a continuous deployment philosophy, so we have lots of deployments every day. And that slows down the team. So in this case, we know for a fact that this is slower to deploy. We still have a cycle time under 24 hours. That includes like median cycle time. But if we compare to other systems where we have less people working, smaller, etc., it is a slowdown in that regard. We do a really hard job trying to have everything with owners, etc. We have chapter, so all the developers of a system get together into a monthly meeting, try to agree how we evolve the system, etc. But there are some places where it's still difficult, like who is responsible for the CPU of the database? Is one database, CPU, yeah, I just use this bit, but the other one doesn't do it. It's really hard to share that ownership. If we had a microservice that a team is responsible for, it's very clear that ownership. So there are some challenges. Now let's go to a microservice example. It's the first one we actually separated from the web shop. That was back in 2017. What does it solve? It has a clear function. It gives you all the pickup locations that there is in a certain address. So, for example, in Sweden, in Denmark, in Lithuania, it's not so popular. Like stores, petrol station, and so on, they become a pickup location. You order something, you go there, you pick it. That was well and good 2017 till we actually got lockers. So lockers is the same idea, but has different function. You have a limited amount of lockers you need to have. You need to know the availability of them. You need to book them, and they are stateful. So each customer booked that locker, so it didn't really fit in our use case, so we didn't use it. So we end up with a change requirement that didn't really fit our first idea. We also realized that that was mainly used by one system, and it was deployed in very similar timing. We didn't have to coordinate because it was decoupled, but if we had a new distributor, then we had to deploy there, but only from one side. And also scale based on one system. So what we end up realizing, it was a little bit of a distributed monolith. It's a separate system, but it goes hand in hand with one. So actually, we decided to merge it back. That's a very controversial decision. There are quite a few people who don't agree with it, but we believe that's the best. Faster, it's simpler, and we put it back into the web shop. We are in the process of doing that at the moment. Yeah, that's a lot of extra work. It requires more effort, so I'm not a fan of that. So. Now, Edward will share another example.
Yeah, but we also have some success stories. So one of the success story was Stock Service API, and it had very basic function. So it had to answer a question: how many items of this product do I currently have in stock? And this is a really important question to answer, because if you're reporting correct numbers, you will be underselling or overselling, which is bad for customer and also bad for you as a company. And what did we have? It was a responsibility shared across multiple systems. They all had different imagination what stock means, and different ways of how to modify the stock. And maintaining the consistency between those systems was really, really painful. So we set to create the microservice, and it actually was a success story. Why? Because we managed to solve the consistency issue. It became single source of truth. It was owning the data, and it only decided what can be shared and the process how it should be shared. Also, we tackled ownership and autonomy thing. In order to create this microservice, we had to choose some, I would say, not so standard technical solutions, technical stack, but just because of the requirements, we had to do it, and because we had that as a microservice, we could do that. And as a microservice, it also has other benefits like elasticity, meaning how fast can it scale, and scalability, how wide can it scale. And a funny story is that one morning the team woke up and they saw that there's a huge traffic increase for stock service. Nothing went down, and we started investigating, and it seemed like somebody just forgot to put the cache for microservice response, and then it had to scale, but it scaled and did it successfully without bringing other systems down. And it also became quite rock solid just because of technology choices, and really, really fast. what challenges did we had to solve? So one of those was, since we introduced a new language into our stack, that was Elixir, well, it's a pain to introduce something new. And you have to do a lot of effort in the platform in order to get the adoption, to get the buy-in. But eventually, because of technical requirements, we managed to do it, and it's being adopted more and more within our platform. Network issues, we had them all. We had split brain, we had lost connections, increases in latency due to reasons unknown. Everything in your book, we found, we had them and we experienced them. Kubernetes, that's another beast. I don't want to talk about it. And single point of failure. As a microservice, naturally it becomes a single point of failure. So what do you do to combat that? You have to introduce failovers. So at the same time we had to introduce failovers, we still want to sell to customer if our service is down, right? So that was the main goal. So we had to find some backup solutions. And actually you can read about it more in our tech blog. I invite you to do that, maybe not now, but after. Yeah, so I hope that in this presentation, you got to see some both pros and cons of each architecture. There's no whites and black. There are many shades between. And what we would like you to bring out of this presentation, or to summarize it, is focus on the outcome rather than technology. And probably you heard, you heard from Martin Fowler, start with monolith. And why is that? Well, just because you have to look at what sort of goal you want to achieve, what sort of outcome do you want to achieve. If you want to start delivering value quickly, if you want to prove your concept, don't go with microservices at the beginning, because there will be a huge investment, a huge things that you have to do around to support the microservices. But at the same time, for example, if you're experiencing some organizational friction between development teams and etc., probably microservices is a good way to do it, because it solves you a lot of challenges. So focus on the outcome, what this technology solves it, rather than the actual technology.
Yeah, scalability and performance are actually opposite, and it's hard to think sometimes, but I think it's true. And here, it's in the system point. We can see like scale probably will have a little bit of performance, it will be a little bit slower, but it's very, very important to think of the teams. So if you want to scale the teams and actually have more performance, maybe microservices is a better. So the teams, having microservices, you can have faster deployments, you can have faster changes, you can have faster performance in that regard.
Yeah, pain. So that's part of software development cycle, and that's natural. Change-induced pain is a natural thing. If you want to introduce some changes into your organization, for example, microservices, it will cause some pain to your organization, but that's completely natural, especially if you have to do it. And with microservices, there's also a thing that if you start too early, you will introduce some sort of pain in terms of financial value that your company generates, because developers will be busy around building microservices. If you're too late with microservices introduction, your product scales too much, you cannot support the load, you cannot scale, you have reached the limits, then it will be a lot more pain. So it's actually up to you as a leader, as a tech leader, to decide when your company is going to experience that pain.
And about ownership, you can find different ways to promote it. If you don't have microservices, you can go a long way with actually a monolith. There are some companies that scale even bigger than us. 40, 50 people, we still think manage quite well. We have quite a good ownership, but starts being a little bit slower. I still think under 24 hours cycle time as a median is really, really good. So we're still fine in that regard. But it is definitely important to have that ownership since the beginning, because otherwise you will not be able to split into microservices ever. It will be forever, and then you will get into a proper mess. And that is it from us.
Yeah. Thank you.
Well, thanks so much. Don't go away, grab some chairs. And Vilus, please welcome back in front. We're going to do a Q&A. And before we jump right into Q&A, jump on your phones again. We'll do a Slido. And there's a poll currently.
I want to be closer.
Yeah, give me a second.
Good job.
We didn't fight at the end. That's a little bit off.
So I'm just asking a question. Let's say everything is a scale, as I said in the beginning. There could be companies that are having too much of a monolith, and there could be companies that are having too much of a microservices, and there could be companies that are having just the right balance. So it's anonymous. When you're responding, we have no idea what your company is. So this is just to get a feel in the room. So half of the people are saying right balance, and majority of the rest is having too much of a monolith. I relate to those 38%. That being said, we'll just jump to Q&A. So I'll stop that, switch to Q&A. Let me see if it works from the phone like that. Yes, it does. So let me grab a chair. I'll join you here. So the first one, how do you manage contracts between services and versions practically? So this is open Q&A, so whoever feels like you have an interesting point to share, just let's do that.
Yeah, well, we have, or we try to adopt the ADR pattern, which kind of allows us to version nicely and then to maintain these versions. Once you are past the version, you can just delete one single class, but that's very specific. The way we implement it is specific to our technology stack. But I agree that it's a really important thing to do with microservice realm.
But Doc Hub we have for documentation, so.
Yeah, that's also true. Like every function, it has an open API documentation, which is then automatically pushed into our Doc Hub with a CD process. So there is a documentation, but yeah, when it comes to versions, it's a difficult topic. I haven't found myself a good practical way. There's a thing that you have to manage, and your company needs to decide how are you going to do. Is it like URL-based version, token-based version, and etc. There are many different ways to do it.
Mm-hmm. Yeah, so I also want to add, there is nothing easy, there is nothing easily solvable. So for us, at least internally, we use Proto, which gives a pretty good, forward-backward compatibility guarantees, and we invest into design to make sure that we can advance. Now, when you can't, there is obviously version next. We work on deprecating previous one. If we have internal usage, right? So only internal usage of API, that is doable. If there is external, basically then it could take months and really a lot of work. So this is hard. So we do, learned our lesson, and we do invest a lot into thinking about APIs, products, and we dread the time when you need to have a V2, let's say, and work on deprecation.
Mm-hmm. Thanks, Phyllis. Let's stay with you. The next one is about Wix specifically. How do you manage ownership of microservices in a big company like Wix?
Easy. Somebody owns each microservice. That is the essence of it. So
the math is 5 microservices, at least.
Yeah, so obviously, it's not all of them would be in active development, right? So the numbers, we also have evolution, let's say, of services. So one would be in deprecation cycle, maybe, some like there are internal services different. But basically, in our system, I can find owner of any microservice. And ownership is usually per team, sort of ownership, right? because people will move, change, and something, and that's simply it. Team owns it. Now we get into more interesting questions if we try to shuffle teams, for example, right? You split a team, and it's again hard. We try to find a home for those services because they sometimes still we try to automate, but they sometimes still need attention, a bit of love. So.
But that thing is not exclusive to microservices, right? So if you have monolith, there's just a bunch of files in core, and reshuffling the teams would give you same exact problems, right? You would have who owns these files now?
Yeah, I guess you can in monolith also. There are packages, there are modules, right? You can also figure out ownership strategies, right?
Yep.
Just the same. So usually in our system, all microservices have an owner, if he even sometimes likes it or not. We try to not keep ownerless things.
So I found the 5-to-1 ratio, if I remember correctly, pretty peculiar. So and I think you were surprised a bit as well. That's bold, right? Do you have any idea how many of them? Let's take 2 last quarters. So somewhere back from summer, what is the percentage of them being upgraded? So you have 2,000 something, right? Microservices?
2,200 something, yeah.
Yeah, 2,200 something. So in the last 2 quarters, how many of them got updated? And yeah,
updated, basically changed to business logic within them, right? I have no clue.
But it's more.
Sometimes you make a service and it's perfect.
Yeah.
Right, and it does its job no, but seriously, it's it can be a really simple.
Some of those 2,000 might be perfect. Yes.
Yeah, I have a service. I showed you. It's really perfect. It just does what it needs to do. It's really simple, stupid, but I sadly don't have data.
Yeah, but it would just be interesting if it's more, let's say, more than half or less. It's just proportion of it. 20-30, you think? Okay, so that's fourth. Yeah. Cool.
I would give a bit bigger number, but well, we both don't have data, so I cannot.
Yeah. We understand it comes with 40% accuracy. How you implemented Saga pattern or any mechanism to ensure transaction between microservices?
We are doing that right now. Yeah, we have a so-called microservice orchestrator, for example, for our product flow, and it basically somebody needs to orchestrate it. And then, yeah, there can be Saga. I'm not really sure which pattern is used right now, but this is definitely a necessary thing when you have to do transactions over multiple microservices, over multiple domains.
What are your numbers, if those are not secret?
In terms of people or engineers to microservices ratio?
Let's do both, the total amount of microservices and then ratio we can deduct, right?
Yeah, I think in a perfect term microservices, we are in the tens. So
2 digits zone.
Yeah, 2 digits. Okay. So when it comes to people, we have around 200 people.
But backend developers is what, 130 services and microservices, so 3-to-1. But the opposite way.
And I guess we're
3 people to 1 service, not the
or 3 teams. So I guess we're on a scale here as well. How micro is micro, and then there's also a question about nano services, and how small do you have to get? I don't even know the actual academic definition when the service becomes a microservice. It's not purely to be isolated. There must be some more requirements in definition.
Definition of microservices.
Yeah.
Yeah, I think that granularity is it says micro, so it needs to be small, but I don't think that there is a clear, definite way to say when it's too small.
Yeah. All right, let's take the next one, Saga. How important is auto-generated code documentation metrics when creating microservices? Does the scale of the company impact the importance?
You read it that so quickly that I
Sorry about that. How important is auto-generated code and documentation and metrics when creating microservices?
So I guess you look at the scale, right? If you would be at 20, 50, 100, I could say you can live really nicely without any of these sort of optimizations to your velocity and elimination of code, you can still have a pretty good life. At our scale, it becomes a multiplier. If we can, whatever we can eliminate from sort of what developer commits as part of microservice, right? It's a win. Then it means like we don't need to maintain it. There is less API surface. We can sort of do changes under the hood, right? We can, let's say, one thing you need, for example, in microservices, well, you need to pass some context across call chain, right? Let's say request or correlation IDs. So now, we have the shared code, and we can sort of fiddle with it. We can enhance it without waking up everybody like all at Wix, do your thing, right? So again, like I think it does have a lot of value, and especially, when you think about organization of 500 backend engineers, 2,500 in R&D. So even understanding what capabilities do I have in a system, it's sort of hard because there is so much happening at any time. So being able to look up what capabilities there are in an easy way. And there are other ways, definitely. So I think it's really sort of a multiplier if you do it right and sort of utilize it. Because otherwise we used to have, let's say, 5 email managing services at some point in time because of rapid evolution. We really, building many products, experiments, and this is where we ended up. And we said, like, okay, we don't want to be there, right? So then we improve and sort of reuse discoverability so that this doesn't happen too much.
So I'll just try to alternate between us, and so let's close that one. And the parcel service, I believe you had that on the screen. So seems your problem was that the parcel service wasn't extensible, didn't cover the storage use case. How do you figure putting it back into Monolith solves that?
Yeah, so I agree. It was not extendable. It was different requirements. We had it completely stateless. It was a very simple system that did it. Once we had to be stateful with that, we thought it doesn't make sense to have longer latency and to change it. But the reason we are merging it back is because we are splitting another chunk of the website. I didn't explain it, of the web shop. So we are going to split the whole checkout. That's in the planning stage at the moment, but we merge it to have a bigger system. So we'll have a full team dedicated to that service, but not just a little small part.
So speaking about dedicated teams and teams in general, let's switch the subject for a bit and let's talk about finance and budgets and stuff. I think one of the questions was, and I'll just extend that question, where the most of budget goes in terms of implementation scale of microservices. That's the original question. So, and I'll just start kind of answering it myself. As you said, microservices, more work, nice counter with, yeah, you want to have it better, you have to put in more work, right? But it all comes down to Benjamins in the end, right? And is it right to think that, yes, it would be more costly in development phase, as in it would require more people, especially if you are migrating to do microservices? But then you would expect to collect the dividends in the future because of lower maintenance costs. Or I just made it too simple?
No, I think that's perfectly described what's the situation. There's a huge investment. If you want to do microservices in an organized way, you have to build teams around supporting these microservices, supporting the infrastructure, tooling, everything. That's a huge investment. Yeah, but at the same time, for me personally, I want to experience that pain a bit sooner rather than later, because eventually we hope that we will scale to the level that we need more microservices. So I bet on this part, that later we scale. So now we pay upfront a bit more.
Yeah. And we'll collect the dividends in the future.
And to keep in mind the growth of the business, because it's one also important thing, both the team and the economics of it, because when you do numbers, how much extra it costs needs to come in more money. Otherwise,
And I think you're in a bit different scales, right? You're somewhat transforming, you're still somewhat chopping it up. and here we have.
We're way beyond
Yeah.
thinking about it.
It's time to merge it back.
I mean,
I'm joking.
no. This is another question is what's next, right? Because we do have microservices now. I don't think it's even really trendy, but then we have other options like platform as a service. Maybe you can like modules is amazing concept. If you could sort of have a dynamic system to shift them around, like maybe eliminate network on hot paths and like this sort of thing, I would take it. Like if I can eliminate sort of complexity. Some sort of runtime complexity and have more resilience, have easier development, because also developing in microservices has cost, eventual consistency, like many things you need to do differently now. So
is it an actual question that sometimes can be heard in your company, let's merge these two services? Or the number will always get higher?
No, this is like merged two services, like it doesn't change anything, right? Let's merge them all together. That would be something, right?
What I'm trying to understand if there's some sort of way back, or it's always more or same.
Actually, we're looking more into having more extensibility reuse, both for us. So it even pushes us to invest more into domain design and actually build them more granular, actually, because then you can sort of abstract them to some extent, make them extensible with different patterns. And also this is something we want to make the platform sort of composable for our users, not only for ourselves. So again, this is like complex, but we're actually even de-chunking services to some extent, not thinking about merging. I mean, of course, somebody somewhere in Wix made a mistake and now is thinking about it, right? With 500 engineers, they do, but...
How would you, so still on a finance topic, these two are really hardly comparable, right? So let's say you have Monolith and your company is on a rapid growth, right? So what do you choose? To launch new features, launch new countries, ignore living on messed up big ball of mud, or say, now we can't launch that country because the big ball of mud is too big by now, so we'll pause the expansion, do this. And that's a conversation where the math doesn't add up, because in one formula you have one-off investment, and on the other end it's a month-by-month saved costs on maintenance.
Myself, the higher the growth, the more I would rush to do microservices. So now we have 16%.
So inverse, counterintuitive.
The more you grow, the faster you want to have microservices. To have more scale, you will grow the team. So if we had, for example, 60% growth, I would be rushing to split it even faster. With a slower cost because of economics and so on, we have more time to split. That's my opinion.
Cool. So I'll take a few more questions. There's load, so fantastic and thanks for asking all of them. Switching back to technical side of things, talking about accesses. Does any microservice have access to all APIs? How do you manage authorization? Open question to any of you gentlemen.
Maybe I can start. We have only a couple of services that are public. So we solve authorization for them a bit differently. But internally, right now, we are using a cloud provider, which gives us a transparent authentication methods. And I don't know if I can tell it. Probably, yeah, I can tell it. It's Cloudflare.
Not bad for it.
Yeah, but basically, we are using service tokens, and we explicitly give access from one microservice to another microservice, from one service to another service. In terms of value for it, we have done it from the past, a long time ago. I personally don't see a good value for it, since we keep everything public. Everything private. So authentication, it's just in terms of security, maybe to limiting the blast radius and etc. But I don't see any value in an organization putting authentication for internal microservices or actually no, restricting access from one microservice to another microservice internally. But that's my personal opinion.
Okay, so I showed this in a snippet. There are permissions that you need to have to call an API. And this is like a whole lot complex. I don't even know half of it, right? Like seriously. But no, you don't have implicit access to everything from your API. You need to have, like, let's say, extra step, do something, grant permission, and like work with it. But I'm really not expert. I mean, at our scale, this is a really complex problem, and I'm just on the surface.
So yeah, not this one. This one is interesting. How do you split monolith when it's under continuous deployment itself?
Oh boy, there are many ways how to do it. I mean, the way we do it, even though a module is under deployment, we, for example, experimented with creating some sort of internal boundaries, internal API, which then module has to communicate with the rest. You still add functionality to that module, but then it is kind of forced to communicate only through very defined interfaces. And then it's later to take it just purely to network. But that's one of the approaches. There are many.
Feature flags. You turn it on, you use one, you turn it off, you use the other. That's basically it.
Easy.
Yeah, but that's how we did the stock service. And actually, we use the same when it fails. We consider the failover we had before. And that's, yeah, it's painful. Sometimes we replicate the traffic to both of them if we want to test the scale or the scalability. So you have both of them running parallel.
My computer keeps logging off, or locking off. So I'll just take the last question from the phone, and I will just encourage for everyone to stay and keep discussing just in a little less formal fashion than we do here. There's 4 people, 1 asking questions, 3 answering. It's very annoyingly official, at least to me. So the last question, and I'll extend it again. How do you manage and find dead unused actions and services? And that, I guess, can be a question for both monolith and microservices, right? So how do you deal with dead code? So we can all take turns on this question and then go to informal discussions.
Yes. That's really difficult in monolith. You will have a lot of dead-end code. So that's why I'm pro microservices myself.
So you would say in monolith, dead code has more chances to keep being alive.
Yeah.
I actually disagree. So you can check APIs. You can go to your observability tool, check that API, and trace the code. So it's not something we do all the time, but you can figure it out.
Would that work on dynamic languages as well?
We don't have dynamic. Everything is.
Yeah. So that argument would be valid for static.
For us, it does. So you go to the API, you check if it's called with the observability tool we have, and then you know whether or not it's used.
Okay.
So for us, I guess we talk about services/operations, right? So we do have metrics. So I guess one way to figure out what is not used, to check into your metrics or low usage, for example. And again, at our scale, I guess, teams that care because they want to own less, deal with it. And this is one of the ways to understand, or even, migrate your users to, let's say, more recent APIs. So this is, I think, how you would approach. And then, otherwise, that code is, I guess we have a bit of it.
So I guess the ownership bit isn't working up till the end. What we try to do in Windows is we're tackling this via ownership problem. So all code should be owned, right? And then you distribute the ownership, and then it becomes an easier task. So instead of, there's a million lines of code, and there's 200,000 of them dead. So instead of it being a company level problem, it becomes an individual team problem, and then you can kind of decompose it like that. We hope it will work, but that's so far the theory.
Yeah, but there's also one more thing. For example, if you have a module and you allow other developers to come and add stuff to your module, they can also add something that you really don't want to be added, or you inherit some function which spans across multiple like modules.
But that's a very broad topic because it involves culture in the widest sense, because we are talking about inner sourcing and how we treat that, quality of our pull requests, and so on, right? So with that complexity, we just pause here, but we continue the discussions after we say goodbye formally. So thanks everyone for joining. Thanks everyone for questions. Hope it was insightful. Have a nice evening.